Good evening, children. So we are meeting after some time, but doesn't matter. Today we are going to start with our subject again. And the very next topic which we are going to discuss today is Introduction to Java. So if you look into a book and if you go through the topics, the very first thing which you come across is about the history of Java. And you will see that there's a big chart or a big list containing number of years and along with them like how things happened and the chronology of the events. But you just remember 3 points which I'm going to tell you regarding the history of Java. The very first thing regarding the history of Java is that it was developed in 1991. Second thing, it was developed by James Gosling in Sun Microsystems, Colorado, USA. And third thing is that it was initially known as Oak. So, regarding the history of Java, these are the three important points which you need to remember. Now, coming to the next topic, why Java is so unique and what makes Java so unique? Notice that Java came in 1991 and right now it is 2020. 29 years have passed since this language came as a platform for development of apps and softwares. You know that in computers things get outdated very fast. So what made Java sustain such a big span of time and basically be usable for 29 long years? There are three important points to be considered regarding the basic and the unique properties of Java, which make it truly unique software throughout the world. And as far as I can figure out, it will be there for another 30 to 40 years. And the most important aspect is that most of the new languages which are coming like in the current years, they have Java as the basic platform. So what makes Java unique? So as I told you that there are three basic points. The very first point is its unique compilation process. Remember, the compilation process of Java is very different from all other languages. Now, those who have any programming ideas or those who have some programming experience, they might be knowing that when we write a program, we write it in a high level language like C, C++, QBasic, Fortran, Logo, all these names which you have come across in your life related to programming, these are high level languages. These high level languages are basically written with English like characters or written in English like characters, and they have been developed keeping the human brain in mind so that it is easier for a human brain to understand and contemplate and to write programs. But computer does not understand English, and thus computer does not understand any of the programming language written or any of the things written in any programming language in our programs. So, with your past experience, you might be knowing and you must have heard it number of times that computer understands only binary. So, what is this binary? This binary is combination of ones and zeros. So, suppose if we write a program in C or C++ and then what we need to do is, after writing the program, we need to run it through a compiler. The compiler will convert this program which you have written in C or C++, that is a high level language, into a combination of one zeros, that is binary, that is also known as low level language. Then this binary will be fed to the hardware of the computer, and the hardware is going to execute the binary generated by the compiler. So in simple terms, in a statement, how computer programs work. We write the program in a high level language. That high level language program is worked upon by a translator. This translator may be a compiler or an interpreter. This translator will convert the whole program which we have written in high level language into low level language and then get it executed by the hardware. So basically what do we see is that there is one stage of conversion, that is from the source code. Source code means the program which you have written, to the machine code, that is the binary. Okay, so from source code to machine code, the conversion is done in one single step. That is why it is known as a single stage translation. Now, just to remind you, you must have studied in your earlier classes that translators are of two types. One is compiler and another is interpreter. Compiler and interpreter, they both do one and the same thing. They both convert from high level to low level. That is a program written in high level language to a machine language program or to a low level language program. The difference is there in their working. High level programs, when converted by a compiler, the compiler will convert the whole program at once. If your program has got number of errors, it will display all the errors collectively so that you can remove all of them together and compile again, and then you get the machine code which will be executed by the hardware. So compiler converts the whole program at once, whereas interpreter converts it line by line. Now what do I mean by line by line? The working of interpreter is different. It takes the program, it takes the first line, checks the first line. If there is an error, it stops there only. It asks you to remove that error. When you remove that error, then what it does, it checks it again. And again, if the error remains there, it will again give you the same message. So the translator gets stuck till and until you remove that error. Once that error is removed, then the whole thing will be, or the whole line will be converted into binary and given to the computer for execution. Then the same process will be started with the second line. So second line will be taken, again checked. If it is right, it will be converted into binary, given to the computer for execution. Again the third line, and so on. So wherever it meets an error, it will stop the process there only. So that is why earlier days interpreters were more prevalent, but with the development of technology, now most of the languages work on compilers because they are more efficient and less time consuming. Now, this is how your general languages work. This is the normal compilation process. So before Java, all the languages in the world of computing worked on this principle. But when Java came, Java developers understood that Java is going to change the way in which the programmers think. Java programs are not going to be written by the developers for a single machine. They will be written by the developers to work basically on internet. That means I write the program here in this computer and I see the output somewhere else on some other computer. Now you must be thinking how it is possible. How is it possible that I write a program on one computer and see the output on some other computer? Children, you have been doing this every time whenever you surf the internet. When you open Google, Google program is not there in your mobile. Google program is there in the Google server. It runs there, gets executed there, and then it shows the output on your screen. This was not possible before Java. So Java made this possible, and how it made this possible is what is the unique feature, or what is one of the unique features of Java. Now, Java has a two-stage compilation process. Unlike other languages like C and C++, where the whole program was getting converted into machine language at once, what Java does is, first of all, it takes the program, compiles it to generate an intermediate code which is not binary. It is a combination of some English letters along with few numbers like MV, A06, FE208. This intermediate language is known as bytecode. So I'll repeat myself once again. First, the Java program will be compiled by the Java compiler JAVAC, and this JAVAC is going to convert the program into an intermediate stage which is not machine code, and it is known as bytecode. These bytecodes are generally smaller in size. Okay, and then these bytecodes will be sent to the machine where the output is required. Like for example, the Google server, the program in the Google server is going to run. It will convert, the program will be converted into bytecodes, and then those bytecodes will be sent to your device, that is your mobile or the laptop from where you are accessing the internet. Now, when these bytecodes reach your device, there has to be a component in your system which will be responsible for accepting these bytecodes and converting it into machine code as per the configuration of your machine. So, to understand the whole thing, once again, Google server will convert the program in bytecodes. These bytecodes will be sent to your machine through the network. Now your machine is going to accept these bytecodes and then convert these bytecodes into machine code as per the configuration of your device or machine. So suppose if I am using a Samsung phone, so these bytecodes are going to come into my machine and will get converted as per the configuration of the Samsung phone. If you are using an Apple phone, so these bytecodes, the same bytecodes will reach your machine, and there it will be converted as per the configuration of the Apple machine. So what do we see is that the source code is not directly converted into machine code. It is converted into an intermediate stage known as bytecode, and these bytecodes are sent to the client machine, that means your machine, where they will be accepted by a component known as Java Virtual Machine, or JVM in short. The work of this JVM is that it accepts the bytecode coming from a different system and then converts it into machine code and gets it executed by your machine as per its own configuration. So here we get to see the two stages of Java. The very first stage where the source code gets converted to bytecode, and the second stage where the bytecode gets converted into machine code. The first conversion is done in the server, and the second conversion is done in the client machine. That means the device in which you are working. Now this JVM is a Java component and it is present in all the machines. Now immediately a question comes up in your mind, that is it present in your device too. So, yes.